Okay, in this chapter in workstation design, we're going to look at design principles and then identify what is a good workstation design and so on. One of the things that's really important here, and you want to make a note of this, is to remember your anthropometry skill sets that you developed, because this ties in. So remember we're talking about designing for 90% of the population, 5 percentile female up to the 95th percentile male, or 90% of the male-female population, that kind of thing. Realize that those skills that you developed are going to be applied for workstation design. And say if you're designing for a percentage of that population would be accommodated, this is where reach and clearance all come into play. So when you were designing, we may be interested in the reach aspects for the shorter people or the clearance aspects for taller people in a workstation design. So keep that in mind, is that you wouldn't be designing for a range now in workstation design. You're designing to accommodate a certain percentage of that population. So let's, for example, if you designed for a clearance aspect of a workstation design, you'd be designing for the taller end, meaning that all the other people who were shorter than that particular stature would be able to be accommodated because of their smaller size. That make sense? In other words, if I designed for this threshold right here, and this design was for a 5th percentile female, then the top of this threshold would be here. But because I want to design it for all people to be able to clear under, including that 95th percentile male, then we're looking at putting that threshold up higher, or to see where it is right here. Does that make sense? So you could do it here for smaller people, but no, I'm not talking about the range. It should be designed from here to here. I'm saying for all people now, it should be up here. That make sense? You'll be tested on this, so make a note of that. So obviously, we want to reduce worker effort, find optimal workstation between comfort and efficiency. This is important. And minimize incompatibilities between the workers and demands of the job. And these are your take-home points. Obviously, you want to improve productivity, safety performance, reduce musculoskeletal injuries and illnesses, and obviously overall cost come into play. So with a workspace now, think about it. We started out with Mrs. Bones, right? We're just looking at the skeletal structure and form and function there. And we've worked our way out by fleshing in Mrs. Bones and what her capabilities are, capacity, and so on. And now we're expanding, and now we're talking about the design of the workspace as it relates to what you learned earlier. So we're really sort of turning the corner on this thing now and going external from the self. Because we talked about all the risk factors. Now we're into this business of designing places in order not to encroach upon those risk factors that I talked about in the CTD lectures. Remember, there's a large variability in size that we look at. Understand the user population, the culture, education, training, and so on. It's really interesting, because I'm doing a project with Bath Iron Works, and that population is totally unique compared to this population. So you have to understand that what populations you're dealing with in terms of age, experience, skills, and so on, and how you communicate this to them. So many of you beginning your projects really need to think about this aspect, because no two companies, I don't care if they're making the same thing, will have the same kind of culture, and you have to make sure that you are able to connect with them on that regard. Worst mistake, design for yourself. Not that if you want to create your own little workspace, that's not a problem, but designing for yourself for other people, that doesn't work. So, seated workstations then. We're looking at following situations. All items needed during routine task cycle can be supplied and handled within the seated workstation. In other words, as you're sitting down, what the heck? Oh, I guess you got the chair. As you're sitting down, things have to be within a range, right, of motion here, and I'll show you that a little bit later. It can't be if something's over there that you have to get up every time, get that, and then bring it back. This is when you're doing some particular work form or function while you're sitting down. Job being performed does not require more than 40 centimeters or 16 inches forward or higher and 6 inches above the work surface. You'll be tested on this, so write this down, that you're looking at something being performed no more than 16 inches out okay? 16 inches out from where you are right here, your chest, and no more than about 6 inches above that work surface. Why? Because when you're sitting down, Mike, I'm going to need your seat for a second. Sorry. Sorry about that. Only for a couple of illustrations here. I'll give it back to you. I'm going to need this too. I find that if I illustrated it, some students like this, some students don't, but for me, I think it helps connect. So you're sitting down and you're working, and we're talking about that reach out. So if I turn sideways, basically we're going out about 16 inches or so. So we really want things designed in such a way that your elbows are next to the body. Does that make sense? And the other thing is that we're saying no more than 6 inches up. If you think, look at my heart right here. Remember what I said? We talked about, things above shoulder level, and I said, no, the new aspect of this is anything above heart level is a problem, right, because of the static loading and the blood flow. So sure enough, as I'm sitting here, this makes a lot of sense, right, in terms of that 6 inches, right? So 16 and 6 is what you want to be thinking when you're at a seated workstation. Everyone good with that? Makes a lot of sense. Because you don't want to be doing this. It's not going to make any sense. And you're not going to be doing this, right? You've got to be doing something within here. Now we're talking about something that you're doing all day. So, okay, I can bring this back to you. Then the other aspect that comes up is how much weight. And that factor is, we're looking at 10 pounds now. We're not talking about something really heavy out there. So the other thing that comes in, it shouldn't be heavier than 10 pounds. So 3 things. Always think 16 inches, 6 inches, no more than 10 pounds. Okay? That's what we want when we're sitting down. And this is an overall model. I know some of you are stronger than that, most of you are stronger than that, but we're talking about an everyday thing, right? What you're doing it, because at the end of the day, that 10 pounds is going to feel pretty heavy. Then we have the job involves writing or light assembly for most of the shift, and the job requires precision or fine manipulative movements that can be form some stability in movement. So what we're talking about is pinch postures here, not power grips, right? Manipulation kinds of work, that kind of thing, where you're doing fine manipulation. And you'll see how all this ties in a little bit later. But that's the kind of work that you would design for a seated workstation. For standing workstations, we have a little different game here. So we're looking at issues where you don't have to worry about knee clearance. So, anything that you get up and work against, for example, let's say here, you can see the back of this. This would be a very poor design right here. But let's say you're working. The good news is that I can get my feet underneath this workstation right here. I have clearance right here, so I can get up a little bit closer, right? Which is great. Same thing over here. The way this is designed and laid out, you can get up a little bit closer, which is good. But if you come up against something that is all the way down, now you have to stand back a little bit, which isn't great. Okay. But the other issue is that if you need that knee clearance, then think about it. This has to be designed in such a way that you can sit down and get your knees underneath, right? So this might be a design question that I would ask you in terms of design something that would accommodate, the 90th percentile or 95th percentile individual to which that knee clearance is adequate enough that they can get their knees underneath a work surface. Either be height or depth. See how that ties in? So when we come up with this right here, we talk about standing workstations. We don't have to worry about that so much because we're standing here and our issue is going to be the height of that workstation rather than having to worry about the footprint of where that is for the knees to be cleared underneath. In other words, you take up less room when you're standing versus sitting down. Then job involves handling objects weighing more than the 10 pounds. Sitting down, 10 pounds. Standing up, more than 10 pounds. That makes a lot of sense. Why? Because if you're sitting down, handling something like this is going to be a lot more burdensome than if you're standing up. Why? Because you now can use the leverage and basically that biomechanical advantage of lifting and moving in the standing position versus being in the seated position. The job requires high, low, or extended reaches frequently. That's this business here. So we're not limited to that 16 inches. Reaching out like this, it's a little easier. Obviously, you want this if you can, but because you're standing, well, this is good. But guess what? Because I'm standing, I can do this better. See that? When you're sitting down, you really can't extend across because of the threshold of the table right in front of you. And then your job requires frequent movement from one station to another. So I'm doing a little bit of work here. I have to pick that object up. I have to bring it around to my other workstation. And I set it here. I do a little work here. Then I have to maybe finish up that finished product. And I put it down here. And then I go back and repeat that process. Right? If you're sitting down, what a pain that is, right? Having to get up each time and sit back down again. And then job requires the exertion of downward forces as in packing and wrapping operations. In other words, same idea here, the concept. Let's say I'm, well, they really don't want you going anywhere with this today. That's plugged in. Anyways, the idea, I'll end up breaking the darn thing, is I'm reaching down in the bend. If you were sitting down, much harder when you think about packing something by pushing down, sitting down versus standing up. Yeah. So the idea is that I can take this stuff, this material, packing material, whatnot, push that down and leverage my whole body with that versus sitting down, which now you only have the forces of the upper limbs. Does that make sense to everybody? You've all experienced that. Thanks, Mike. But those are some very clear advantages and disadvantages between seated workstations and those in which you stand at. And it's not fun to stand all day long. I mean, many of you who've probably been in the service industry, food industry, and so on, if you are a receptionist, people coming in, I've seen mixes of this kind of thing. My big thing would be a sit-stand workstation, and we'll talk about that a little bit, where you can just sit on a stool, and you're still kind of standing up, but when you're also taking some load off your lower limbs so that the fatigue doesn't set in, and then boom, you're up real quick, versus a chair that you're just sitting down in. And I've seen some places, I'm trying to think of, maybe Outback Steakhouse. I think I walked in there a couple of times, and I've seen the receptionist sitting down in the little waiting benches there, because they're tired. They're just waiting. It's not always people coming in, so on and so forth. It just looks bad, right? People sitting over there, and they really should give them a sit-stand. Or how about the Walmart greeters, right? I mean, some of them get it, some of them don't, but usually these are elderly people, and you give them anti-fatigue mats to stand on, right? It takes a little bit of load off their body, which is always nice. So these are all these come into workstation design. Sit-stand workstations, as I mentioned, frequent reaches of more than 16 inches forward, 6 inches above. Job consists of multiple tasks, some best performed in the sitting position, others while standing. In other words, the thing that really comes across is a sit-stand workstation. So this is about the height, about 30 inches or so, a little bit higher on a sit-stand workstation. You've seen them. They're small little platforms. Don't get them on rollers, by the way. A lot of them like to do that. The problem is sit-stand workstations, the things can take off on you, and next thing you know, you can go down and really hurt your tailbone. The idea is that something like this, you just sort of rest up against it like this. Someone comes in, boom, you're up. Right? If you're sitting down all the way, you can imagine what after a while it just gets kind of old. So this is where the sit-stand workstations come into play. And they're very helpful. Also, take the body weight off the legs, ability to avoid unnatural body postures, lower energy consumption because you're not getting up and down, less demand on the cardiovascular system, more stability for precision tasks or fine manipulative movements. So what's nice about this is that not as good as sitting down and resting your elbows, but in this position, being a little more stable does help versus standing and trying to do the work. Why? Because it's more fatiguing to be on your feet all day long. And ability to operate foot controls more easily and safely, and that is just basically activation of presses and movements of parts and things of that nature. So then general principles then, work. What the worker must see on the job, what they hear, how they perform, the sequences of the activities, clearances required, and if storage is required. I would like to talk about this because my wife is forever putting stuff underneath, the footwell where her feet are supposed to be. And I said, yeah, you're all cramped up there. I said, I wouldn't be comfortable at all doing that. Or underneath your desk, you got stuff. It's crazy, with the storage thing. So I always try to say, again, I'll get that area cleared out so you can stretch out your legs. Why? Because if your hamstrings tighten up and you stand up, now you've got tension in the back, and you say, where'd that come from? I've been sitting on my bum all day. The idea is, well, what's happened is the ham's tightened up, so when you stand up, everything else is now tight. Right? So if you can stretch out your legs while it's underneath the table by not having storage there, then you're fine. Then we have to know the clearances. We'll talk about that. Sequences are important in terms of one thing to another. And then, obviously, knowing the work you do, what you can hear, and also what you can see. The senses are so important, especially the interaction between the two. So key considerations then, anthropometric data, the nature of the job, behavioral patterns of employees, what they're willing to accept and do and change. Obviously, money comes into play, enhancing the worker's efficiency, good postures, minimizing fatigue, and health and safety risks have to be minimized. We want to design then for the user population, the one that we're interested in. So I would design differently for you than I would design for, let's say, people building battleships. Workspaces must have adequate clearance, avoid unnatural postures. And a lot of times you can get in these confined spaces and so on, not very comfortable at all. So the idea is that, pre-think what you're going to do and then try to get in as comfortable a posture as you can. Design more for sitting than standing if you can, if the footprint will allow you to do that. Our movements should be in opposition to each other and symmetrical. In other words, movements like this, coming together like that, rather than kind of doing this sort of thing, trying to find some symmetry in that. Doesn't work as well. And then all tools and parts should be placed in logical order when you're assembling things. Use rubber or padded strips to cover the edges. Avoid twisting. As I mentioned to you a couple of times, for the ladies, basically the iliac crest coming into the sharp edges of work surfaces. Like this, working up against them, very uncomfortable. So padding the edge is helpful here. But also, padding the edges is great if you're doing a lot of elbow work, right? Leaning on that, because now you've made this much more comfortable for that ulnar nerve not resting on that and basically causing some problems, as I mentioned to you, with that differential diagnosis with the nerve issues in the pinky finger and the ring finger versus the medial nerve issues that are in the other digits. Avoid twisting where you can. Avoid combinations of stretching and lifting. And again, that's that forward flexion, lateral rotation we talked about, the combination of the two. That's really a bad situation to be in. And avoid repetition, high forces, awkward postures, especially in combination with each other. So what you're maybe thinking about here is that, what you're telling me is obvious. You don't even have to be intuitive about it. It's very obvious. But you'd be surprised the number of things that are designed that you're not taking these kinds of things into consideration. And it really is important, because it becomes very obvious after something's designed that thing is bad. That's a bad job. But when you're looking at this ahead of the game, you can say, okay, I'm going to really design this in such a way that we're going to try to avoid as much of this as possible. Can't avoid all of it, but as much as we can. So on the seated workstations then, here's our normal and maximum reach distances. How far are we out here? What'd I say? There you go, 16. Come on, in color. Of course it's going to do that. 16 inches out. Ooh, yeah, I know. You freaked out, didn't you? I know. There we go. Yeah, it looks like a little bit of a brow of a windshield wiper, doesn't it, the way that looks. That's your normal reach. Your maximum reach is out here. This is right out about 24 inches or so. That you're looking at. And what that is, if you think about it, that's your distance for most people in terms of the reach. My reach is a little bit longer because I'm taller, but really the reach from the shoulder to the middle of the palm, right? And that's what you want in terms of your maximum reach right there. On occasion, this is not a regular part of the job, but for the ones that you're doing all the time, 16 inches or less, no more than 6 inches above the heart, no more than how many pounds? 10 pounds. There we go. So seated workstation, you're going to do what I call the right angle rule right here, that the upper leg and lower leg are 90 degrees to each other. The torso and the upper leg are 90 degrees to each other. The upper arm to the lower arm are 90 degrees to each other. And the key there is when you start out in this position. If you start out in this position, doesn't mean you have to stay in this position. If I look around at all of you, some of you started out in a different position than you are right now. Why? Because you're constantly shifting, right? The spine, as you know, needs that passive diffusion of blood, nutrients, and minerals, and so on. And that's why you move around so much. But also you feel the pressure, right, on the buttocks, on the gluteus maximus muscles, and it's causing you to constantly shift back and forth. The key concept in design is that you have to get into this position initially, be able to do this, then you can change in any other position that you want. If it's designed in such a way that you can't get into this position, then you're going to be uncomfortable all the time because this is where your starting point is. Make sense to everybody? If you're shorter, then you want to bring in a footrest and keep everything else in the body's fine. Why is this important? Because most desks are going to be standard height. And you say, well, can I get a desk that would fit me and come down? Yes, you can. But it's going to be very expensive and it's going to be cost prohibitive. And the idea is that better to design the chair and a footrest around the stationary platform of a desk. That's why we do that. A little bit taller, then you can adjust the chair accordingly as you need. Okay, so here's where you would get something in terms of a design question. Notice you've got foot clearance here. You get your feet underneath. Over here, same thing. But let's say I wanted to design this, say, what's the height of this? Number 4, knee room height. And let's say I'm interested in knee room depth. Let's say I'm interested in calculating for that population of what worker. Do I really concern myself so much with the smaller population in looking at knee room height or depth? Am I more interested in the taller person or the smaller person? Taller person, right? So this is the difference now, what you did in exam 1, where you were calculating for a range. Now you're calculating for a percentage to which if that clears, the rest of them are going to clear. Okay? So this is something that I would be interested in using that anthropometry question to be able to address how high should this be? Let's say to accommodate, I'm just going to make this up. Let's say to accommodate 95% of the male population. Because I know if I've got that covered, I can go all the way down to that 5% female, right? And the reason for that is that I can accommodate that female then with a footrest, right, to bring them up to where they need to be to accommodate this taller individual right here to be able to fit under this. But the other thing is that knee clearance, right? Being able to have that knee clearance in front. So now instead of looking at the popliteal, right, which we were doing for the height of the chair, right, the seat pan, we're now looking at this clearance right here in terms of where that threshold is on the desk on how far in they can go. So this is your cutout. This is what it would look like on the inside. So this right here is this, right? Just reverse that. And the idea is that where is my foot room? Right here coming up. And then where is that clearance for the knee underneath? So this is the kind of thing that we'd be looking for that taller population, male. And if we've done that, then we know that, okay, a shorter female or shorter person, that knee is only going to go about this far. And in terms of length, maybe that foot's only going to go about this far. And so we don't have to worry about the smaller end. We've just now designed for the larger end. So here's some numbers to look at in terms of adjustable table and seat height, fixed table and seat height. We can move around, so we'll be designing here, let's say, for that fixed percentage. And this is a percentage fitted, so on, for seat height, minimum, maximum values, range of adjustability, table height, task or table height, footrest height. So in this case, we may be looking at what our range is over here if it's fixed. And we can look at adjustable. It gets a little more complicated over here because we're adjusting things up or down. But if we're adjusting, though, for the fixed height and then the adjustable seat, then all we have to really worry about is what accommodations we have for that table. Because the seat, the chair, is going to help us adjust to be able to fit in that percentage. Now we just have to worry about clearance, as I mentioned, and only for one end of the population, not for a range. So anti-fatigue mats are coming into play. They do work. You can feel the difference if you're standing all day on a cement floor versus one that's made of linoleum like this, or tile squares, versus one that's made of wood, versus one that has a rubber interface like this. Real quick, if I were to ask you, what can we do for something like this for someone who really does have some foot problems, and you really can't afford to have the rubber mats because they're moving from one point here to here to over here, and you say, wow, that's a big rubber mat. You know, it's not only perhaps a trip hazard, it's very costly to do that. What would be your recommendation to be able to try to achieve that same accommodation? Yeah. Sure. You put basically rubber insoles inside, you know, any maker out there, Dr. Scholl's and so on. Of course, they're getting really clever now, right? Because now they have these little machines in, you know, near the pharmacies where you stand on. It looks at basically your pressure, right? The pressure distribution. Said you should get these versus those. You know, it's amazing the marketing they come up with. But the bottom line is they do work, and yes, that's cost effective. So, and when we're getting involved in the type of work being performed, I will test you on this, so please circle that one there. And this is precision work, light work, and heavy work. Recommended height. Very important. We have males and females here, mixed, so you may see something like this come up as a test question, asking you, okay, what's the type of work being done? So recommended work surface height for standing, so circle that. Standing workstations. And what's fun about this says precision work, drawing or sorting fine items, light work, assembling small items, heavy work, metal cutting, and so on. And here it says 2 to 4 inches above elbow height for precision work, 4 to 6 inches above or below elbow height for light work, and then 6 to 16 inches below elbow height for the heavy work. And here are your ranges that you can see for males and females in the mixed population. Now, obviously, you're going to make some corrections there. Note the fine details below. So I may give you this question, and I may not put that in here, and I'll expect you to remember that because you've already been tested on it by knowing that shoes can make a difference in terms of adjustment of height. So if we do have shoes in there, we want to make sure we add that in there because that's going to change the height of where you're going to look at the body. So very important concept here. And this is also on the exams that people take to become certified in ergonomics and so on, is that they want to make sure you understand, you know, what it is that you measure on the body. So if I'm talking about a standing height workstation, and you see it right before you, but if you had not had this information and I were to ask you, what's the most important part to measure on the body for standing height, you might think, well, it might be maybe the height of your hips. It might be the height of your shoulders. It might be knee height. It might be inseam height. But in actuality, what it is, if you think about it, which makes the most sense, is elbow height from the floor up to the elbows, because for the work surface, that's where you want to be. This should make a lot of sense to you. Right here, where you want to be. So if you're doing precision work right here, the recommended height is what you're going to have is, let's say you're working, let's say right here, this is up a little bit higher. Then you want that about 2 to 4 inches above that work surface because you're doing precision work. You can see what you're doing, and the elbow is going to be at an angle. So this is your reference point from the floor to here. You'll be heard. Now, if you're working with something that's more in the light work area, such as assembling small parts and so on, notice this is 4 to 6 inches below the elbow height. So now, standing where I am, it's right here, right? I'm going down to it. Why? Because I can use more forces, right, in this position. But now if it gets to heavy work, think about this. Now what I really need to do, you get into heavy work, now I'm going into more of a well. See, going further down. Why is that? Because again, as I showed you a little bit earlier, being able to leverage your body and the weight from your body, right, the upper limbs, the torso, and so on, to be able to do this heavy work. So that's a very important concept. You will be tested on it. So know the importance of those positions. Precision work above elbow height, light work below elbow height, heavy work, significantly below elbow height. I'm into it. Okay. A little higher workstations. Okay, this just covers the same thing. What this is helpful. I will not test you specifically on these numbers because it's, again, this is not a class in memorization, but a class really in delivery of an understanding of concepts using critical thinking. And that in this situation right here, this is very helpful. That if you go into, let's say your project involves looking at a workstation, redoing it, for example. I don't know, and I have some fun with the Starbucks people over at the Union because it's actually your building, but Starbucks acts like it's their building. Let's say you wanted to redesign for them and make it more accommodating for the students that work there. These are data that you can use to actually help redesign workstations to accommodate the majority of the people working there. So very helpful in knowing seat height in terms of reach, tabletop height, and so on and so forth. Do the designers for such companies have this kind of information? They do. But more often than not, they'll go in and they're going to design for aesthetics, and then a lot of times after that, designing it for form and function. So very helpful to have this kind of information in terms of workstation layout. So easy access can be provided by allowing adequate workspace, obviously, enlarging the size of openings, getting in and out, eliminating barriers and obstructions between the worker and items needed for the task. So just clearing a path, right, can make a world of difference. Rearranging the workstation components, such as equipment, tools, and shelves, removing all objects which interfere with visual tasks, in other words, line of sight, right, in terms of safety. When we look at rounding and padding of edges, we talked about that a little bit, a number of factors when you're standing. It can be for protecting the hips. When you're sitting down, for the elbows, changing the work surface height of the seat, in other words, to get more natural posture, providing armrest, redesigning the job. That can be a major aspect. And I think by the end of this class, you could probably go out there and do a pretty decent job redesigning. Minimizing pressure on the legs and feet, changing workstation layout to eliminate leaning on a table, reducing the size of the workbench or table, rounding, padding, and edging, work surface height, changing that, obviously standing on padded mats, wearing cushioned shoe inserts, as we talked about a little bit earlier, redesigning the job. Awkward postures here, changing the workstation to keep the worker's elbows at their sides instead of up like this or forward, avoiding reaching down into boxes and bins and tubs. And that's really by taking, something like, let's say you're reaching down inside, say this is an open container. The idea is just putting a wedge on the back of that, tilting it forward like this, and now having much easier access to reach down and out. So like this, just much easier. You can see the parts, see what you're getting and so on, just angle it. And all you have to do is just put a little wedge on the back of this thing versus, let it down, Mike, have it now reach down inside like here, come up against the edges and so on. It's a simple concept, but it saves time and it works. Did I lay that again, Mike? It's over here. So, summary of design principles then. Key is all dimensions should be determined based on relevant anthropometric data. Workspaces must have adequate clearance for the user's head, torso, arms, knees, and feet. Largest people, that's what you're designing for, determined by the amount of clearance needed. Bent or unnatural posture should be avoided. Keep the arms outstretched either forward or sideways should be avoided. In other words, this stuff here or here, out in front of you or off to the side, try to avoid that. Designing the work for more sitting than standing, less body fatigue. Arm movements should be either in opposite direction to each other, otherwise symmetrical. These kind of movements here. I mean, you've never really seen a conductor, right? Conducting going this kind of thing, just kind of just weird, right? They're always symmetrical. And then location of the working field should be at the best distance from the eyes of the operator. In other words, and we're going to talk about this a little bit later in lighting, but for example, for my vision, being able to read what's on the board behind Mike right there, I can really see the larger print, like the right choice and so on and so forth. But to get to the smaller print and say, well, what is the right choice about? I have to get a lot closer to it. So if that's critical information, then that information should be larger, right? So it just now, the right choice, this is now it turns out it's the Seattle University School of Law. Okay, bringing you up here, kind of interesting being advertised here. But getting up and reading, the fine details of this. If it's emergency information or critical information, it needs to be large enough so that wherever you're working, to whatever you're observing, can immediately be seen without having to leave what you're doing and come over and take a hard look at it, right? For example, when you see the exit signs, right? We know that in the color spectrum, this is the area that really lights up for the cones, right? The color. But there's a design aspect to the height of and width of these letters, an exit. So it's not only the color element to see it, it's also height and width. So you can see this from the back of the room. And that's where the design aspect is. Just like you can see the exit sign in the back where you are, it's actually this thing is designed for those in the back corner of the room to be able to see that clearly and easily. We'll get into that a little bit later, but it's important in terms of workstation design. So summary then, all tools and parts needed by the worker should be placed in logical order. They should be pre-positioned in such a way. So I'm a fan of having workstation layouts where you drill holes in the table and there's your screwdriver, there's your pliers, there's your hammer, and so on and so forth, where it's all laid out in a logical process for use. All tools and parts must be placed within a comfortable reach distance, which is how many inches if you're sitting down? 16 inches or less, right? 10 pounds or less in terms of weight. Handwork can be done easily by the supports under the elbows, forearms. So there are a lot of advocates out there that favor slings in being used. If you're doing work all day long, slings are used. I found them to be somewhat cumbersome after a while, but there are advocates of that kind of use. Use rubber padded strips, cover sharp edges. Torso twisting action should be prevented. Combination of stretching and lifting and placing objects at a distance will increase the load on the back. What's the worst position to be in? There's two. The combination I've given you several times, because that'll be a quiz question. That's an easy one. Forward what? Come on, PTs. Flexion and lateral rotation. Forward flexion, combination with lateral rotation. Now, why? Because you've got the support of the torso and the upper body, but also you have to put a weight out there. Now we have asymmetric loading, and that's a recipe for a bad back. Okay? So if you see a quiz question said forward blop, lateral blop, you know what that is. Lifting heavy or bulky objects should be avoided. And notice this, it's heavy or. Okay? It can be heavy and, which most of you understand, but heavy or bulky. Why is that? Important concept is, let's see. Let's just look at something like that. I don't know. Let's call this somewhat bulky. It's not really that bulky. Here we go. Not that heavy, right? And not that bad if I'm holding it like this, because I can hold it up next to my stomach, right? But if this obviously the orientation is different, and I have to hold it in such a way that one arm is here and the other arm is, out here, now it becomes pretty bulky, right? Because of that, the weight didn't change, but because of the bulkiness of it, my posture did change, and because the posture changed, now the forces on my back are going to be much greater in this position versus this position, right? So heavy or bulky can make the difference. Why? Because of the unnatural postures you have to get into. And the weight of the torso and the arms is a result of that. And wrist bending, repetitive tasks, and so on. This is basically that kind of ringing motion that we're talking about, and twisting like this, flexion, extension, right? Radial, ulnar deviation, any of those. And we experience that when we rotate it. Example of workstation design problem. This is where we're talking about determining the heights convenient for the 90th percent of the 50-50 percentile of a mixed workforce performing heavy work or workstation design. You've seen this information before, so here we're looking for our mix right here, and now we're looking for design then of 50-50 mix, 90th percentile, right? Convenient for 90th percentile, that's the upper end that we're looking for. And depending on what we're looking at right here, there could be sitting height, knee height, and so on. So now these parameters are all going to change if we're looking at seated workstations versus standing workstations, which would be here for that percentage on the 50-50 mix. And so you remember your Z-tables right here, and the idea is to go through in this exercise, and then I'll work with Josh to go through this exercise with you just for the sake of time today. But the idea is that we're looking at that 90th percent right here. We're not looking at the between one group and the other. We're just looking at this one right here on down, okay, for that. So this is where we'd focus. In this case here, we talked about now if we're looking at a recommended workstation height standing, if I were to give you the question on, let's see, if I'm doing precision work, then I want to do it for that 90th percentile, then we would be looking at something that would design it here. If I said heavy work, we'd be looking at design of something here. So the idea is that we'd come up with the height of that work surface, right, for that 90th percentile, and then anything less than that in terms of what that would be. So that would be a design consideration. So I'll have you practice that one with Josh so that you understand how to work that out. You've already done it in another way. It's just applying it now to a workstation design concept. Okay, I'm going to go through these kind of quickly. This is an aluminum plant nearby. Issues here are basically moving these aluminum shafts, from one point to the other. Look at the position that he's in. There are potential slip issues, obviously slip and fall. Also, if just one of these falls off the table, it could hurt the person. And in the background, you see a couple of hygienists actually off making really good money now. They graduated a few years ago, documenting this information. They're actually students, taking this information down and recording what's going on. Every single recommendation the students came up with, they made changes at this facility. It's a great international facility, by the way. Another local plant right here. Do you see any risk factors with this? The easy ones you can see in terms of posture and so on, but also think about some of the hidden ones. Notice this worker is supporting not only the weight of the tool, but the weight of the power connector to the tool. So the idea would be to suspend that power connector so that they don't have to support the weight of that in addition to the tool. And a balancer would be kind of nice to be able to support that position. But again, this is a fixed work surface height, and this female worker has to get herself accommodated to that position to be able to drive home these things. After a while, they can have an impact on the quality of what's being assembled. So if they don't look and realize what an important resource they have right here with this worker, they certainly get the message if they're putting out defective products, right, where there are quality control issues. Right here on Purdue's campus, 5-gallon container. We still do this today. Very awkward posture trying to lift this up here, a female trying to do this work. And it's a significant amount of weight. Milk is very much like water, so you basically use 5 gallons. And you can do the math very quickly that you're up a little over 40 pounds on this. An easier thing would be to have a tray to be able to come up to this and be able to slide that right into position and to pull it out. In this case here, if it slips out of her hand, she's got an issue. Replacing shower curtains and so on, this is your static loading. We talked about that before in terms of putting these hooks. They should have quick hooks to be able to hook on instead of these metal tips right here that tend to switch around and cause problems. But a lot of these the service workers have shoulder problems, mostly from the static loading that you see here. This lady here, she couldn't have armrest because she's, it's a larger lady, but she was very comfortable. She's incredibly brilliant. This is the one who is building parts for the space station. Absolutely brilliant lady. Notice that how she used her workstation in terms of pulling out a drawer to increase her surface area for working on things and rotating around. Notice that she has 2 different kinds of chairs that she uses for the different type of work being done and so on. And she had a whole kind of ideas, but I did a lot of work at NASA in Cleveland when they were putting together specialized parts for the space station. One of the kinds of things. And you come across people like this who are just absolutely brilliant, and they incorporated. They're not really thinking about their own comfort. They're thinking about the mission of what they're doing. So they're always appreciative when you come by with some ideas that might help improve their work conditions. Just some precision work. Notice the pinch grip here being used by this one. Another part being designed for the space station. Awkward posture using a microscope. Lighting is fine. But you can see, doing this over a period of time, look at her left hand, what I call a bio clamp, right? So your hand, right, is a bio, the clamp, using it, hold it down. She should really have a carpenter's clamp or a quick clamp to be able to hold onto that piece so she can free up that left hand. Because at the end of the day, you say, well, that left hand didn't do a lot of work, but it's really tired. Said, oh, it did a lot of work. It basically was used as a clamp all day long. This one here, local plant, again, I had wire harness issues and so on. You can see they had these quick ties used to hold these things in place. And then what they expect those workers to do, if you look at this lady's forearms and her biceps, this is a strong lady, right? She's well-defined muscles and so on because she does this job all day long. What their strategy was back in the day was to bring in physical therapists and say, we're just going to make you, do the right thing in order to assemble these things. It was a poorly designed job. I don't care how good a PT you are. You're not going to make their job better by saying, do this and not that. It's just not going to work. It's just, it was outside the range of most people in order to do that properly. They redesigned it so that now that most of these engines where the wire harnesses just drop right into place and they cinch them off rather than trying to press them into these smaller positions. And this is one of the tie guns that were being used. And you can see here, this one actually went off to Ford Motor Company, one of our former students. And the problem there was the trigger gun was too small for the fingers, causing problems. Keyboards, and you can see it's a little bit older VDT. This worker had lots of issues between using the mouse and so on. So as you know, you can redesign it so you can use the left hand or the right hand, and that's what was done. Made their job a lot easier, and so we moved it over to the left side, and they were really happy because they really couldn't use that right hand anymore. This one here, this NASA worker had passed away, but this guy, he had polio as a child, but he did all the calculations for all the space shuttles that ever took off. He basically did all the things for the thrust needed, so on and so forth, so that when these things ignited and went off the pad, it was based on what this guy did. And he said, well, it's sad to say, you can see this government desk and so on and so forth. My home workstation's a lot better than this. But he said, this is what they give me. And this is what I come up with. Just an amazing guy. And then this is, last but not least, was talking NASA into changing out some of their older chairs because they tend to hold on to things a lot longer than they should. And we talked about being basically a 4-legged chair versus a star base, right, the 5. Turns out that one of these legs, when they break, you have much greater likelihood of falling over and hurting yourself than with a star base. Star base, you may lose your balance and catch yourself a little bit if a leg breaks or bends. This one right here, if that breaks or bends, you're going to go down. Right? So it was that safety reasoning that I was able to use to get some of these chairs out of there. Okay, job analysis. We're moving along. We're going to do this. In terms of interviewing the supervisors and employees, you have informal versus formal. Reviews. And so one is structured. That's your formal. Workers interviewed get specific information about work elements that may be hazardous. Supervisors can help you. Soliciting input from both workers and supervisors invites them into the process right here. This is a secret for successful ergonomic interventions or the process. When you get that work or the supervisors to buy in, when you can get them to buy in, that makes all the difference in the world. So reaching overhead, we saw this. Changes and occur. I'm going to just move through these to get right to this. Stacking of dishes is a problem. Extended reaches. Yeah, this is really an issue right here. Over the knives and stuff and having a slip. My goodness. Sharp knives, that can be a problem. Reaching in the hot ovens in terms of height. Right there, look at that. You can actually see that. Anyone eat over at the Ford Food Court? See them doing the pizza stuff? Like that. It's great. The pizza's great. I always go in there and I get that little piece. And I call it the no-calorie counting slice before I sit down. But you can see over there the shorter workers, they can now actually stand up on these little wood platforms to get in there without burning their arms, which is nice. And just moving these pizza trays around, moving these carts, which tend to be very heavy. These floor mats, you got to watch out. We tend to color these a little bit better to define the edges so they're not trip hazards. And then taking measurements. Why do you want to take measurements? So with your ideas about what you're going to go out there, if you're trying to do a YouTube vignette, you want to sketch or draw the areas with measurements, right? So you may take a picture, but you want to get the XYZ coordinates, right? The height, width, and depth of things. And then you want to label those dimensions and the heights and reaches and so on with an individual in place. One of the things I like to do, it's a little kind of a little trade secret, is I know my height at 6'2". So a lot of times what I'll do is I'll photograph a particular workstation, but then what I'll do is I'll turn it around and photograph myself in it. So anywhere I look around, I have all my reference right there of my height, and now I can get an idea of the relative height differences and depths of what's around me. That makes sense, everybody? So a lot of times just photographing yourself in an environment so you can get an idea of the relative differences can really be helpful. Interpreting results. Step 1, you want to break the job down into the task. 2, the job is broken down into the task. You want to determine the methods being done, the workstation tools needed. And 3, what are the specific tasks, force, posture, frequency, and so on that go into interpreting the results for risk factors. And there is a breakdown to this, which I'll show you in a minute. But you want to look at strength data, who has capabilities of doing this kind of work, force requirements you need to know, biomechanical models, static or dynamic. And in this class, we will use the static models to do this. Anthropometry comes back into play again, obviously with body size. And then the data also available. NASA is a great source for this information. And you can use this to generate computerized models, avatars, and so on. In terms of the physiological data, we want to look at loads being required. Useful data is, in this case here, 13 to 30% lower for women compared to men. And again, this is not the difference between the genders as much as it is leveling the playing field so everyone can perform the same job. So that's important to know those differences. Energy expenditure there, not to exceed 33%. You saw that a little bit earlier. And then your limits here, 5.2 kilocalories per minute for the average person, 3.5 for females. So know this. Most physiological data is most useful, or psychophysical, excuse me, most useful when applying this to dynamic tasks. In other words, what's psychophysical? Remember again, it is what the person feels comfortable doing when you give them a task. It's not what you're measuring, it's what you're asking, right? Very important concept. And then we devise our limits to all of this based on that information and feedback. Best method when determining if a task is acceptable or not to a work population. Integrated models are pretty sophisticated here. The NIOSH lifting equation is just such a model. And you know already, we originally developed in 81. It was revised in 91 and stayed the same ever since. Not that it's perfect, it just hasn't moved forward, which I'm really surprised about. Developing solutions and results suggest a number of ways to eliminate or reduce control hazards. When it's not feasible, reduce production rates, improve additional rest breaks, periodically rotate workers, add more workers. This thing here is a real tough sell. When you're talking about how much slow down your productivity, no, they don't want to do that. They'll be much more creative about stuff if you stay away from the production side of the equation. When you're dealing with documentation, permit the analyst to track the progress of a job, provide a compendium of facts, useful facts, provide a track record of successful solutions so you don't have to reinvent the wheel, and then a foundation for the overall evaluation of your sex to move forward. And this is the outline for an approach that you might want to take. That's why I moved your deliverable back to Thursday. Here's your report. If you know, what's your purpose, defining the problem, the layout of the area, worker population, your statistics, discomfort survey information, interview findings, what's your procedure in terms of you gather, that's your methods, what did you come up with in terms of conclusions and recommendations, and then of course your references are important using APA, and then any appendices in the report to support what you did. So an example here would be your background, production of printed circuit boards. One step involved removal of impurities and so on. Problem identified, 8 of the 12 workers experienced some kind of pain. Recommendation, attack the biomechanical hazards associated with maintenance operations of this job. In other words, they triaged it. Instead of all the things I could be looking at, we're going to go after the biomechanical solution. Very much like I asked you to do a sensitivity analysis on, was it the horizontal, was it the frequency of lifting, asymmetry, and so on. And most of you nailed it. You knew exactly what to do in terms of redesigning the job. This is what's happening here. And then, so use of checklists then, designed to help you discern where the problems are. Rapid screening, the right checklist is important. And by the way, there are a number of checklists available in that book that's in the pharmacy library on cumulative trauma disorders. There are a whole bunch of them there for you, including your own workbook. Hang on, give me one more minute here. Expert versus a worker, right here. The expert assessment's good. The drawback, though, you may not know the company culture. Interventions are usually implemented after the expert is done, but really having someone built in. So my recommendation when I worked on the Bath Iron Works group is to say, you need to hire someone there that's 24/7 kind of a thing. That made all the difference in the world rather than calling someone up to come in and look at it. Also, it should be very helpful in providing recommendations. Education training is important. And all that said is that when you walk away from this, know there's plus-ups to the expert, there's plus-ups to the in-house people. At the end of the day, it's the in-house that really is the sustainable element. Thanks for your time and attention. Have fun with Dr. Cole on Thursday. Please be nice to her. She's soft-spoken. See you next week, Tuesday.